Hey everyone, it's Mrs. Allward again, and this is our last lesson for our polynomials unit. So here we go. We are going to do one more thing with our factoring, and that is something called our zero product law. It says if the product of multiple factors is equal to zero, then at least one of the factors must be equal to zero. All right. So the law can be immediately put into use in this first exercise. In this exercise, quadratic equations are given already in factored form. So basically, what we're going to do is we're going to take each of the factors and set them equal to zero. When I was in school, we used to call this T bar. Okay. Kind of looks like a little T chart. Um, And then we're going to solve for x. We're going to make little mini equations. So most of them are one-step equations. Sometimes we're going to have two-step equations, but they're pretty quick. Okay, so here we go. So the first one we have x plus 7 times x minus 3, and it's equal to 0. So really what we like to do is we just make this little t-chart. Okay, break it up so we can separate our work. We're going to have x plus 7 equals 0 and x minus 3 equals 0. And all you have to do is solve for x. So on this side, we're going to minus 7 from both sides of the equation, and x is equal to negative 7. Over here, we're going to add 3, so x equals 3. And we're done. That's all there is to it. All right. In B, we have 2x minus 5 and x minus 4 equals 0. So again, we're going to t-bar it. And 2x minus 5 equals 0, and x minus 4 equals 0. Sorry, I wrote so big on this side. So first thing we have to do is add the 5. 2x equals 5. But we're not done. We got to divide by 2. So 5 divided by 2 is 2.5. So that's that side. And over on this side, we're going to add our 4. So x equals 4. And on the last one, there's actually three factors. We have 4, 3x plus 2, and 4x minus 3 equals 0. So we have to t-bar all of them. 4 equals 0. Well, that just doesn't make sense. Okay, so we're going to cross it off. We're going to talk about that in a second. 3x plus 2 equals 0. So we're going to minus 2 to both sides. So 3x equals negative 2. Divide by 3. That's going to give us a nice repeating decimal of negative 0.6 repeating. So you can either write that or leave it as the fraction, negative 2/3. Both ways are fine. And then lastly, we have 4x minus 3 equals 0. We add the 3 over. We have 4x equals 3. Divide by the 4. And 3 divided by 4 is 0.75, or you could leave it as the fraction if you want. So those ones were a little bit more interesting with some of the decimals. That's okay. But the exercise 2 says, why does the factor of 4 in part C have no effect on the solution set of the equation? And that's because there's no x variable. All right, so it really just kind of disappears and goes away. We're going to get more into what um, these X terms mean in our next unit, because we're going to look at this factoring and this solving in a more graphical way in our next unit. Okay, so the zero product law can be used to solve any quadratic equation that is factorable, not prime. To utilize this technique, the problem solver must first set the equation equal to 0 and then factor the non-zero side. So I have a few more that are already factored for us that we can set up and solve. and then some that we need to factor. And that's going to use all of our different types of factoring. So GCF, difference of two perfect squares, and then our SPF. Okay, so let's take a look. These first three are already factored for us, so we can set up our T-chart. So if it was too busy kind of just drawing the line in between the factors, you don't have to. If you want to do x plus 1 equals 0, then draw your line, x minus 3 equals 0, okay, and separate it like that. That is totally okay. So on the left, we're going to minus 1 from each side, and x equals negative 1. On the right, we're going to add 3 to both sides, and x equals 3. Notice how when you don't have that coefficient in front of x, your x is always equal to the opposite sign of the number that's in the parentheses. Okay, let's take a look at the next one. So we have x plus 7 equals 0. Break it up. X minus 2 equals 0. And then we can solve for x. So on the left, we're going to minus 7, and x equals negative 7. On the right, we're going to add 2, so x equals 2. Not too bad, right? All right. Last one that's pre-factored for us. So 2x minus 5 equals 0, and x plus 3 equals 0. All right. So we have a plus 5. So 2x equals 5. Divide by 2, and x equals 2.5. On the right, we're going to minus 3, and x equals negative 3. And we're all done. So the next problem, we have x squared plus 4x. It's a binomial. There's two terms. We have x's in both parts. So this is GCF. And we can take an x out of both terms. So our GCF is going to be x. You don't have to write that if you don't want to. So we're going to take an x out. It doesn't disappear entirely. It comes out front. But if you like to show that division so that it mentally, sets up the situation for you, you can do that. So x squared divided by x is x. And then the x's cancel here, and we're left with the plus 4. Set it equal to 0, and then do your t-bar. So x equals 0. Boom, there's nothing to do there. It's all set for you. And then x plus 4 equals 0. We minus our 4, and x equals negative 4. Okay. Next page. So all of these we're going to have to factor. I've set them up nicely for us so that all of our GCFs are together, then all the SPFs are together, and then our difference of two perfect squares. All right, so let's take a look at the next example. We have 3x squared plus 10x equals 0. So 3 and 10, there's nothing we can take out of those, but each term has an x, so we can take out a GCF of x from each term. So I'm going to write x, and then in parentheses, what's left after I take out that x. So I'm going to bring down my 3. X squared divided by x is x, plus the x's cancel here, so I'm going to bring down my 10. Then I can t-bar everything. So x equals 0. That one is all set. And 3x plus 10 equals 0. So I'm going to minus my 10. 3x equals negative 10. Divide by 3. Oop, running out of space here. And x equals, that's going to give us a repeating decimal of negative 3.3 repeating. So you can write that, or you can leave it as the fraction negative 10 over 3. And you're done. Let's take a look at the next one. We have 2x squared minus 14x equals 0. So we can divide a 2 out of each of the terms and an x. So we can divide out 2x from each of these. So our GCF, 2x, then in parentheses, after we divide by everything. So the 2's cancel, X squared divided by x is x, minus 14 divided by 2 is 7, and our x's cancel, set it equal to 0. Now we can do our t-bar. So 2x equals 0, and x minus 7 equals 0. Divide each side by 2. Well, 0 divided by anything is still going to be 0. And then over here on the right, we're going to add 7, and x equals 7. I don't think we can get through the rest of this page in our 15-minute YouTube allotment. So I am going to stop the video here and pick up in a part B for our last 6 examples. And I will be back in just a moment for you.